Okay, here we are in Chapter 1 again, the whole numbers, and we're on Section 1.7 now, the solving equations by multiplication and division. 1.6 we added and subtracted. This time we're doing multiplication and division. So as we did with addition, if we multiply both sides of the equation by the same quantity, the solution set does not change. Or if we divide both sides by the same quantity, same thing. So if we start off with a equals b, we can multiply by c on both sides, and that's an equivalent equation. Or we can divide both sides by c and also have an equivalent equation. And this is only true in both cases if c does not equal 0. Now, if we had c equals 0 here, that would just give us 0 equals 0, which doesn't really help us. And we cannot divide by 0 if we remember from earlier, and so we don't want 0 in those cases here. So that's why c can't be 0 in both of those. Now, multiplication and division are both inverse operations. So if we start with a number x, and then say we multiply by some number a, and then we divide that result by the number a again, that returns us back to the original x. And how that works is, so we start with x, and if we multiply by a, then we'll have ax. But then if we divide by a, well, if you think about that, when you divide by a, those cancel, and then we get x again. And so that's how it's working. So first, if we do the division, same thing works. If we have x originally, then we divide by a, and then if we take that product or division, multiply it by a, well, guess what? That's really a over 1, and so that cancels that, and we're back to x equals x. So we can always go from one to the other by dividing by the same number as we multiplied by. And so that's going to help us be able to solve certain kinds of equations, because sometimes we'll have an equation, maybe we'll have 2x equals, I don't know, 4, okay? And so that would be kind of like this a times x. And how do we get rid of the 2? Well, if we divide it by 2, and we divide that side by 2 in this case, then we have equivalent still. And so when we divide those, we get back that original x. And so that's how we decide what we're going to divide by. Or in this case, if we had x over 4 equals 3, well, how do we get rid of that 4? Well, if we divided by 4 here originally, well, that means we're going to have to multiply by 4 based on this. So we're dividing or multiplying by the same thing. And when we do that, we have to multiply that side by 4 to get the equivalent equation. And so when we do that, that 4 cancels that, and we get x, and then we have the 3 times 4. So this is how we're going to solve equations using these two kind of operations, undoing a multiplication or undoing a division. And these are examples here. We're going to actually work the numbers here. And so it says 3x equals 21. Well, we want x. Well, how do we get rid of 3? Well, if we multiply by 3 here, that means we're going to have to divide by 3 here. And what we do on one side, we have to do on the other side. And so when we think about that, that 3 divided by 3 cancels, and we just get x. Now, if we don't know how to do the 21 divided by 3 in our head, we have to go back to long division. Now remember, the 3 goes out front, 21 goes underneath. Now 3 times what is 21? Well, 3 times 7 will give us 21. If we subtract that, we get 0. So 21 divided by 3 is just 7. And so that would be our solution. Now, does it check? Well, 3 times 7 equals 21. Well, 3 times 7 we know is 21, so it does check. Okay. Now here we've taken x and divided by 7 initially, and that's supposed to be equal to 12. Well, if we want to get rid of that 7, what do we have to do? Well, we have to multiply by 7. And if we multiply by 7 there, we have to multiply by 7 there. And when we do that, that 7 cancels that 7. We get x. And then we have to do our long multiplication. So we go ahead and line them up. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. And so we get 84 as our solution here. Now, what does our check say? Well, it says 84 divided by 7 is supposed to be 12. Well, let's check. 7 goes into 84. Well, 7 goes into 8 once. Subtract 8 minus 7 is 1. Bring down our 4. 7 goes into 14 twice. That's 14. Subtract, that's 0. That's 12. That's what it's supposed to be equal to. So that does check out. Okay. And again, the checks are really important because then you know you've got the right answer before you even are done with the quiz or homework, exam, or whatever. You know you've got the right answer. All right, here we have back to word problems, and it's going to work the same way as before. We're going to read it. If we have to, we reread it. Then we look and see what kind of things work. You know, is there a picture to draw? Is there an equation to use? Or is there just a variable to assign? And then we just kind of go from there. Well, it says 7 times a certain number is 105. Find the unknown number. Well, they give us what we're looking for, unknown number. So let's call that n, okay? And so it says 7 times the n is 105. So basically, we've written it kind of in long form here. So 7 times n is 105. All right, so we have the 7 times n. Well, what does that say? Well, we took 7 times this, so if we undo that, we have to divide by 7. So that means we have to divide by 7 on both sides to make it an equal equation, equivalent equation. So 7 divided by 7 is 1, so we get n equals. Now we actually have to do a long division here. 7 into 105. Well, 7 doesn't go into 1, but 7 goes into 10 once. And we have to subtract. 10 minus 7 is 3. Bring down a 5. 7 times 5 is 35. Subtract, we get 0. So it looks like n is 15. And so that is our number. So does 7 times 15 equal 105? Well, I don't know. Let's try. So 15 times 7, that's going to be 35. It's going to be 7 plus 3 is 10. That equals 105. So it does check out. So basically what I did was I did the 7 times 15 there, which is that, and then that's supposed to equal 105, and so it does. And so our unknown number is 15. So you could say the unknown number is 15. So if we had to write it out longhand, that would be our expression we would type right out. And if they just wanted n equals 15 or some variable equals some number, we could do it that way. What about area of a rectangle? Okay, well, rectangle, that means, hint, hint, we have to draw a rectangle to see what we're going to do. So let's draw that before we do anything. So we know that's the rectangle. So it says the area of a rectangle is 7,500 square meters. If the width is 50 meters, find the length. Okay, well, what do we know about a rectangle? Well, we know that the short side is usually the width, the long side is the length. Okay, and it says we want to find the length. So what we're going to do is we're going to say, well, L is the length, and that's what we're going to look for. Okay. Now, what do we remember about area of this? Well, area is just going to be length times width. Remember, the number of columns times the number of rows would give us the number of individual pieces in here, which would give us area of each of those, and then we add them all up and we get that. Well, so area is length times width. So now we just plug in what we know. Well, we know the area is 7,500 is equal to L, well, that's what we're looking for, times, and width says 50. Okay, so now we've plugged everything into the equation. That was the equation we knew. We drew a picture so we knew what it looked like, so that was 50, and that was meters. And this one is one we're looking for. So what do? Well, we have to solve for L. So if we multiplied here by 50, we have to divide by 50. And what we do on one side, we do on the other. So those cancel, and we just get L. Now we have to do again some long division. So 50 goes into 7,500. Well, that will go in once. We have 50. Subtract. 5 minus 0 is 5. 7 minus 5 is 2. Bring down our first 0. Now 50 times what is 250? Well, if we take it times 5, that will give us 250, because if you think about that, 50 times 5, that's 0, that's 25. So that's 250. Subtract that 0, bring down another 0. Oh, that doesn't go in, so we get L then is 150 meters. Okay. Now, does that make sense? Well, we're going to say the length of the rectangle is 150 meters. So that's kind of one of the ways we can look at it, either as L equals or the sentence. And so now we have to take and simplify and see if it's true. Does 50 times 150 equal 7,500? Because we're taking that 50 times that 150. So as I wrote it, that really doesn't help us at all. But remember, if we take and move that 0 over, that makes us have less to do. So now we can just take and drop it down, and then we just take and multiply those three. And so 5 times 0 is 0. 5 times 5 is 25. Carry the 2. 5 times 1 is 5, plus 2 is 7. We get 7,500. Well, guess what? That's what we're supposed to have. And so that is the true length of the rectangle. All right, so here we have a class of 44 students averaged 87 points on an exam. How many total points were accumulated by the class as a whole? All right, so what does that tell us? Well, we have a class of 44 students, averaged that many points on exam, and when we want to know is how many total points. So maybe let's call that T, okay? So what do we do to find averages? Remember, the average is equal to the total, maybe in this case, since it's already labeled as points, we'll take total points divided by number of students. Okay, and that should give us our average. Well, how do we find that? Well, we plug in what we know. We know the average is 87. Total points, well, that's what we're asked to find. So we'll call that T like we said. And that's divided by the number of students, that's 44. Okay. Now, what do we do now? Well, here we divided T by 44 and we get this. So we have to get rid of that by multiplying by 44. And if we multiplied by 44 here, guess what we have to do here? We have to multiply by 44 here as well. That will cancel and we get T equals, now we have to multiply 87 times 44. Well, 4 times 7 is 28, carry a 2. 4 times 8 is 32, plus 2 is 34. And since those are the same numbers, we know that there's nothing here that's going to be an 8, a 4, and a 3. And we can do that because those are the same, so we just use the same numbers here, as long as we're pretty sure we did it right. And we add. So 8 plus nothing is 8. 8 plus 4 is 12. Then we carry that 1. 4 and 4 is 8, and then 3. So the total points appears to be 3828. Okay, so total points is 3,828. So that's what we say is our total points. Now, does that really work? Well, what we're going to do is we're going to plug in and say 87 equals 3828 over 44. And now we have to do that long division. 44 goes into 3828. Now it doesn't go into 3, 44 does, and 44 doesn't go into 38, but it goes into 382. So we're going to have to take 44 times what? Well, if we take 4 times 8, that'll give us a 32. So I think I'm going to try an 8. So it's 32. 32 plus 3 is 35. And I think that's as good as we're going to get. So that's 8. And so then we have 352. We subtract 2 minus 2 is 0. 8 minus 5 is 3. Now we bring down our 8. Well, 44 times what will give us an 8 here? Well, 4 times 8 is going to be a 2. So 4 times 7, let's try that. So 7 times 4 is 28. That's 28, 29, 30. And so that looks like it's good. So 308, subtract, that's 0. And 87 is what we said the average would be. Okay, so that one does check out. All right, so that's all I have for this part of the lecture.